Welcome, dear students. Starting with today's lecture, as I have told you earlier that in aircraft, a special type of refrigeration system is used that is called air refrigeration system, which is different from the air conditioner which we are using over here, because in aircrafts a completely different system is used in which a cooled air is taken from the atmosphere, and that cooled air is, after taking from the atmosphere, is compressed. It is initially compressed without any cost, because when we trap the air that is moving outside the aircraft, it automatically get compressed, and thereafter it is compressed by an air compressor, and then after cooling and expansion to 1 bar pressure, because in cabin passenger used to sit, that air is given to the passenger. A completely different system is used, and there are 6 types of cases for this system, because as I have told you earlier also, because in aircraft beside cooling we want cabin pressure also, means cabin pressure of 1 bar. I have told you in my previous lecture that airplane used to fly at very high altitude, and at that altitude the pressure is very low, because in each and every question you can see, if you go for solving the questions also, you will see that when the air is taken from the atmosphere, the pressure is very low. You can see on this slope, this is a constant pressure curve, because on TS diagram there is no place for pressure. The pressure is shown by a slope like this. This is a constant pressure slope. 0.2 bar is the pressure, because when the aeroplane is flying at very high altitude, the pressure is very low. And if at this pressure, if you give cold air to the passenger, it will be hazardous for the passenger. So that's why the air is compressed, air is cooled, air is expanded to what pressure? 1 bar pressure, and then it is given to the passenger. I have told you in a previous lecture that if air pressure is not maintained, what will happen? A news of Airways was shown to you, in which the pilot forgot to maintain cabin pressure and passenger lose hearing, because such a low pressure creates problem in the eardrum, and the final hearing ability was lost. So you can directly know from here that if cabin pressure is not maintained, what will happen? Now we will start with the lecture, because we have to cover all the systems, because in each and every system the air is taken from atmosphere. First is the simple air cooling system. Second is, in air cooling system, if we use one more heat exchanger, means after compression the air, instead of cooling in single chamber, if we cool twice, means if after compression air is cooled once, after compression air is cooled once, and again it is being cooled, air is cooled once and again it is cooled, then twice it is cooled, then it is called simple air evaporative cooling system. Now similar is the bootstrap. In this we use 2 compressors, and if we use evaporator also in bootstrap, then it is bootstrap evaporative. Fifth one is the ambient, because we use ambient air for cooling, that is at reduced pressure, that is why called reduced ambient. And the last one is the regenerative, because air which is going to the passenger for comfort, that air is regenerated and being sent for cooling. Now in this way we are having 6 type of system. The basic was explained to you earlier also, because the basic thing is that we have to compress the air. How we have to compress the air? It was shown to you that if we go through the Bell-Coleman cycle or reverse Brayton cycle or Joule cycle, the same concept is used in all air refrigeration systems, because when we study IC engine cycles also, all are based on Carnot cycle. Similarly, all air refrigeration systems are based on Bell-Coleman cycle or reverse Brayton cycle or Joule cycle. In this, what used to happen? Because starting with the cycle, we have to anyhow compress the air. That is being shown to you. You have to compress the air. You have to cool that air in a heat exchanger. You have to expand. You have to expand the air. It is being shown to you over here that the air is expanded. The expansion is carried out At what pressure? At 1 bar pressure the expansion is carried out. And later on at constant pressure that air used to get heat up, because as the air enter the cabin, it gets heated up. This is a closed system being shown to you because first and last point is joined. But in aircraft, what used to happen? The first and last point are not joined. If we go through the aircraft reference system, the first and last point are not joined because we can't give the same stale air, because once the air is being compressed, such a long compression is being done from this pressure to this pressure, and after expansion, after cooling, this is the cooling process, the air is expanded and it is given to the passenger. Now the air has become stale, or means the air has become saturated with the as it has entered into the passenger cabin. So that air can't be used again and again. So again the fresh air is used. That's why it is an open cycle. The last point and the first point are not joined. Now we will go through one by one all the systems, because certain things are common in all the systems, whether we go for the first system, second, third, fourth, fifth and sixth. Today we will cover one numerical also, that how we have to solve the numerical. The numerical are based on the same concept for all the 6 systems. Now starting with the first one, that what used to happen in the 6th system. Whenever air reference system used to work, it used to take the air from atmosphere. Here you can see this is the point 1. This is the pressure, that is called ambient pressure. From this pressure the air is being taken and air automatically get compressed. This compression is free of cost, because whenever we stop a moving thing, its whole kinetic energy used to get converted into another energy. Here it is getting converted into the temperature rise, and second one is the pressure rise. You can see as soon as the air was stopped, we have taken the air from the atmosphere. This ramming process takes place and air gets compressed free of cost. For this one image I have taken, because image I have taken from net also. This is the pack inlet scoop from where the air is taken, because if the aeroplane is flying at very high velocity, means if it is flying at sonic velocity, speed of sound, then what will happen? The air outside will be at the same velocity. If such a high velocity air is stopped by this duct, because you are collecting the air from this duct and this is the outlet duct. If you are collecting the air from this inlet duct and this air is being taken inside, all the air kinetic energy will get converted into pressure and temperature. That's why a small slight and a small pressure and temperature rise is there. This is observed in all the cycles, because anyhow you have to take the air from atmosphere. This is the first point, ambient air, and this is second point, ram air. Here all of a sudden get converted and its terminology changed from ambient, the name changed to ram air because of stagnation. As air is taken from atmosphere, that's why in simple air cycle the same system is being shown to you. Air is taken from atmosphere and it gets converted into the ram air. Simple is in the air evaporative system also. What you will see, the air is taken from the atmosphere, means the first process is common for all the systems. This is the first process. This causes slight increase in pressure and temperature, and this is achieved during the first process, whether it is simple air cooling, whether it is simple air evaporative, whether it is bootstrap. This process can be seen over here, whether it is bootstrap evaporative also. In bootstrap evaporative also you will see the same process, means the ambient air, that is the 1 point, get converted into the ram air, and this is being shown to you over here also. The pressure get rise. In regenerative also we see the same thing. The ambient air, means the ambient atmospheric air, used to get converted into a ram air, and slight increase in pressure is there. So this first process is ramming, and this is common for all the all the systems in simple air, reduced ambient, bootstrap, and regenerative. All the system, the first process will be the common, and 1 to 2 process is called ramming. The second after 1 to 2 is 2 to 3. What used to happen in 2 to 3? That is also common for all the system, because this compressed air used to go inside the compressor. From this compressor, a certain amount of air is needed, because major portion used to go for running the gas turbine, but a certain portion is bleeded air. The portion which is being bleeded means from the compressor, the portion of the air which is bleeded, that particular air is used and it goes through all the process, and after expansion that air used to go to the cabin, to the passenger. The mass of this air is not known to us, because a particular portion of air is needed. For this, what we used to do, we used to calculate the refrigerative effect by two methods. One is from the question itself, that how much refrigeration is being done, MA, mass of air, CP, and delta T, because at the last the air used to go to the passenger and it used to get heat up. We have to determine that at what point it used to get heat up, and that delta T is used. MACP delta T is the formula that is used for refrigerating effect, and the same refrigerating effect is determined if the value of ton of refrigeration is given. Suppose if the value of ton of refrigeration is Q, they have given in the question, then what we used to do, we used to multiply Q with either 210, because in most of the question of Khurmi, the writer which I am referring over here, they have converted the ton into kilojoule per minute. But in certain cases, what we used to do, we used to determine, if we are doing the question in SI system, we used to convert Q into kilowatt. We used to multiply Q by 3.5. As soon as we equate the two things, we move means this factor, the factor which is being shown to you over here, this factor is moved over this side and MA is determined. In this way we determine the value of MA. Now the second process is common for all the system, because I have told you 1 to 2 is also common, and 2 to 3 the compression is also common. 2 and 3 is an important term, because we used to get the work done in all the system, whether they are using one compressor or two compressor or three compressors. In this system they are using two compressors, both the bootstrap compressor system, but the work done is determined by 2 and 3 only. How the temperature 2 and 3 are determined will be explained to you. So starting with the first system, the air which is being shown to you is ambient air, and as the ambient air is trapped, it is stopped, it gets stagnant and pressure rises. Now after this, the air is compressed. The compression process is 2-3, which is being shown to you. If it is isentropic, then it is 2-3. The work done is to determine by 2-3 itself in all the 6 systems. Means if they are considering the work done for the complete system, if we are going for the work done, you can see the work done for the complete system is 3 minus 2, and 3-2- we have to determine anyhow. In this way, what we used to learn, that the temperatures are important, means we have to somehow determine the temperature. In simple aircraft reference system, what used to happen after means 1 to 2 ramming, 2 to 3 is the compression, because air used to go into the compressor and certain portion bleeded out. 2 to 3. 3 to 4 is cooling. That 3 to 4 process is being shown to you. This is cooling. A constant pressure cooling is there. And thereafter, from 3 to 4 they have cooled. And 4 to 5. 4 to 5, what they have shown is 4 to 5 they have shown the expansion process. In 4 to 5 they have expanded it. We have to expand to what limit? That is 1 bar pressure, so that passenger feel convenient in having this air. That is shown, that is 4 to 5. And 5 to 6, the last one, that is 5 to 6, which is being shown. This is called refrigerating effect, because 6 point you will never see in this figure. As soon as the air enter in the cabin, that is the 5th temperature. This is the 5th temperature. The air used to get heat up through passenger, and it is it gains the temperature 6. So that's why the last temperature is never shown in this schematic figure. Similar is the simple air evaporative also, because in simple air cooling we used to have single heat exchanger. In evaporative we used to have two heat exchangers, means twice we are doing the cooling process. 1 to 2 is the ramming that is shown, 2 to 3 is the compression that is common for all the six systems. 2 to 3 means 1 to 2 and 2 to 3 will remain common for all the systems. 3 to 4 they have cooled in the first heat exchanger, and 4 to 5 they have, and 4 to 4 dash. 3 to 4 they have cooled in the first heat exchanger, and 4 to 5 they have cooled in the second heat exchanger, and later 4 to 4 dash, sorry, 4 to 4 dash they have cooled in the second heat exchanger, and later 4 dash to 5 they have expanded. 4 dash to 5 they have expanded. This is being shown to you over here. The 4 dash to 5 they have expanded, and this air used to go inside the cabin and get heated up. Now, what thing which is important in this means whether we are going for simple air evaporative, whether we are going for the bootstrap, because bootstrap the compression means compressed air, because we all know that we have to initially compress the air. We have received certain compression free of cost, that is ramming. From main compressor we have received certain compression. Now we have to reach to another pressure. For this, after inter means a certain cooling, again it has been compressed, and we have reached this compressor, means twice the compression process is carried out in bootstrap, because when we are considering the bootstrap system, twice the compression process is carried out. But even though twice compression is carried out, the burden will be 2 to 3, because this is what I explained to you. The burden is always the main compressor, that is 2 to 3. We have to somehow determine the temperature 2 and 3. In bootstrap evaporative, because in simple bootstrap we are having the two cooling systems, and bootstrap evaporative we are having 3P system. One evaporator is also there. Evaporator is filled up with certain fluid, and that fluid used to evaporate and give cooling effect. In beside this, in reduced ambient, what used to happen? In reduced ambient, we take the air that is ram air, and after reducing its pressure, after reducing the pressure of ambient air, that air is used for cooling. Means 1 to 2 process will remain same as it is, and all the systems we have free of cost compression is there because of stagnation. 2 to 3 will also remain common, means we have to somehow compress the air, that is compressed by the main compressor, and certain air is bleeded. This is the bleeding bit which is being shown to you, and bleeded air quantity we used to determine by a formula. Then it is cooled, the refrigerated air that is going, which will go to the passenger, that is cooled. This is being shown to you in this chamber. This is also shown. But how the cooling is being carried out, means how this cooling process is being carried out, that is shown to you. This is carried out by reduced ambient air. What used to happen in this? The air which is being shown, this is being cooled. This air, ram air, ambient air is reduced pressure, and this is being used. That's why when we deal with a heat exchanger, means when we are dealing with the heat exchanger, this is the actual temperature drop which has taken place. If we consider this as 0.1, this as 0.2, this as 0.3, and this as 0.4, then actual temperature drop is T3 minus T4. Means what we are getting, T3 minus T4, and another fluid which is touching this is at different temperature. This is at T2 dash. Means actually the T2 air was entered, but after expansion it has become to a different temperature, that is called T2 dash. So that's why when we draw the figure of main cycle, that will be different, and when we draw the figure of means heat exchanger, a different figure will be used, because in the heat exchanger which is being shown to you in the figure, a different air is used, and that air was entered at what pressure? Means that air which is being shown to you, that enter inside this heat exchanger at T2 dash pressure, and that gets cooled to T2 double dash. When it come out, is being shown to you. It is at T2 double dash. For this, that's why the reason for main system means air is going, and after compression it is being cooled, and it after expansion it used to go to the cabin. For main system we are using a different figure. This is being shown to you. And for heat exchanger we used to draw different figure. For heat exchanger we used to draw different figure because in heat exchanger the air used to enter at T2 dash and exit at T2 double dash. T2 double dash. Air entering and air coming out. We will cover up one by one the numericals. I am starting with a simple case numerical which I am going to cover is RGPV June 14 numerical. The question is that a simple air cooled system is used for airplane having 12-ton load. This question is in your book also because simple air cooling system they have mentioned. So starting with a simple air cooling system, what they have done, this is question 3.2. Instead of 10 ton, because the reference system was of 10 ton, they have changed it at 12 ton. We will cover up this question. The one thing they have changed, that is instead of 10 ton, they have written 12 ton. The rest, the remaining question is same, means 0.9, 10 degree centigrade. All terms are same. So we will start with the numerical. What they have written, if you go through the question, a simple air cooled system means a simple system is there. We have to just compress the air, cool the air, somehow expand so that passenger should be able to take that air. What pressure we have to expand? The pressure was explained to you earlier also that it should be 1 bar, and this air is to be given to the cabin. And first and last point shouldn't be joined because again we will take fresh air from the atmosphere. And the compression process was split in two parts, means here we have second point. One is free of cost, 1 to 2, and 2 and 3 is the work done. This should be known to you. Now starting the question, the atmospheric condition they have given, that is 0.9. 0.9 is the atmospheric condition, that is P1 and T1. P and T at this point they have given. And pressure increases by ramming they have given because free of cost pressure they have increased to 1.013 bar. If we stop a moving thing, automatically the pressure will rise. They have shown to you over here. Now if we draw the figure of this, the ramming is being shown to you. The ramming efficiency is not shown to you, that's why we have gone vertical. If they would have given the ramming efficiency, then we have moved slightly like this, because the efficiency would have come and actual ramming would have been like this, 1 2 dash. And isentropic ramming should be 1 to 2. But they have not given the ramming efficiency, so they have drawn directly the vertical line. Whenever we got vertical line in TS diagram, that is called isentropic process. Whenever we get vertical line in TS diagram, that is called isentropic process. And what used to happen in isentropic process, what used to happen when we get vertical line, a simple relation is used. The relation is that whatever T means, what simple relation is that we used to get this relation. This is the relation being shown to you over here. We have to use this relation whenever we get vertical line. I have told you earlier also. Here the vertical line is at 1 2 and 2 3. Twice they have used the relation. Means they are using the relation at 1 2 2 3, and 4 5 is also vertical line. They might have used. They have used at 4 5 also. So whenever you get an isentropic process, means vertical line on TS diagram, you have to use this relation, and you know very well that from one equation you get one unknown. In this, what is happening? At first point they have given pressure and temperature, and second point they have given the pressure. What pressure they have given? The pressure which they have given is compressed to what bar? Pressure increases to 0.013 bar. Means P1, T1 and P2 are given. T1, P1 initial and P2 are given. You have to determine T2, and gamma is known to you because you know that gamma is Cp upon Cv, and that you have to learn from your home itself that it is 1.4. By this they have determined that T2. Similarly, they have applied this formula on 2, 3 also, because this is also a vertical line, and they have determined the unknown because out of the 4 terms, first, second, third and fourth, 3 are known, the unknown they have determined. And this formula, what you have to consider in mind when you apply this formula, that you have to keep temperature in Kelvin, because this formula used to work whenever the temperature is in Kelvin. There is no means the ratio should be is will be correct when the temperature is in Kelvin. And then lastly, they have applied the formula on 4, 5, and what they have determined at the last means all after going through all these steps, because these steps up to this, starting from the question, this point, this much thing, and this much thing, and up to this, they have used for determining only temperatures, the requisite temperatures which are required, because without temperature we cannot obtain the work done and refrigerating effect. Later on, what they have done, because they have used this formula, because Q was given ready-made in the question itself, that what ton of refrigeration system is there. It was given in the question that refrigeration system was of 10 ton. In the paper it was given 12 ton. I have told you that there is only one method, one and only one method to determine the mass of air that is going through mass of air which is bleeded. Because when we go through any question, a certain mass of air from compressor is bleeded out. Maximum portion goes for running the gas turbine, otherwise the plane will come down and crash. A certain portion is bleeded off, that is called MA, and this MA air without anything, if it is not reduced, if it is not regenerative, the complete MA air used to go to the cabin. There is one and only single formula for determining MA, that is MA CP, refrigerating effect delta T, and ready-made refrigerating effect, if it is given in the question, that is ready-made refrigerating effect is 210 into Q if you are going through the Khurmi book, or 3.5 if you are using the SI system into Q. Anything you can use. And MSCP delta T is important at what refrigerating effect you are giving. As soon as you determine this CP delta T, you have to divide below it and you will get MA. The same thing they have done in the question also. The question which was shown to you in the which I was solving, they have determined the MA. MA CP delta T 6 minus 5 was the cooling effect, because as soon as the air enters the passenger cabin, it used to get heat up, and at this particular point it has heated up. The 6 is being shown to you. It has got heated up to 6 point. This will be the refrigerating effect. You have to determine T5. You have to determine T6. As soon as you determine T5, T6, CP is 1 point something for air, and this was given, you determine the mass of air. Now they have gone for the work done. I have told you in all the 6 cases the work done is MA, CP, and delta T means 3 minus 2. It will be 3 minus 2. So you have to determine the 3 and 2. And if the compressor efficiency is given, then this 3-2 process will be like this. And you have to determine 3 dash. One thing you have to remember, that whenever the points are on vertical line, they are determined by that relation that was shown to you. This is the relation. You have to learn this relation. And whenever this point is not on vertical line, it is determined the efficiency formula, because for dash, whatever point which is given in the dash form, you have to use efficiency formula. That is also simple. Whenever there is compression, the efficiency formula is CIA, means isentropic will be above isentropic delta T upon actual delta T, and from this you will get the 3 dash point. You can use this. That is also simple. And after determining the MA, what you are seeing over here, after determining the MA, they have determined the power, because for power they have to divide it by 60. And if you divide refrigerating effect upon work done, you will get the COP also. means refrigerating effect you can get by two things. Either you put 210 Q or either you put MA, CP and delta T wherever the refrigerating effect you have achieved T6 minus T5 in this question. Either of the two things you can use. And power you have determined. If you divide both the things, means refrigerating effect upon work done, you directly get the COP of the system. Similar are the other questions also, because tonnage should be known. They have already given the ton. If the ton is given, you have to directly divide the ton into 210. The ton is 30. This is also refrigerating effect, and this formula, this is also refrigerating effect. By equating the two, you will get MA, and from MA you will get all the other things. In each and every question, what you have to do, the second question I am showing you after this 3.3, what you have to do, that you have to somehow from the starting, from this portion to I am drawing the vertical line, this portion, up to this portion, what they have done, they have determined only and only things that is called temperatures. And for determining temperature, whenever they get the vertical line, means 1, 2, 2, 3 and 4, 5. They have used this formula. 1, 2 they haven't used, 2, 3 they have used, 4, 5 they have used. You have to use this common formula. And whenever you go like this, means compressor efficiency is given. Whenever you go like this, you get a dash point. And for this, compressor efficiency is to be used, that is CIA. Isentropic temperature increase should be above and actual should be below. And you will get the dash point. Means whatever dash point is there, one unknown is determined. And opposite is used for turbines, because turbine used for expansion. For turbine, what used to happen, instead of CIA, CIA, isentropic won't sit in the numerator. In this turbine, what will sit? Actual will sit. Actual will sit in the numerator, and actual will sit in the numerator, and isentropic will sit in the denominator. And what wrong they have written in the book itself, that for turbine they have used the term actual increase in temperature. In turbine there is no increase in temperature. You can already see turbine there is a decrease in temperature. So there they should have used actual decrease in temperature, that is lower, less, means the value is less. Actual decrease, the value is less, and isentropic decrease, the value is more. So that's why they should have the term decrease instead of decrease, and all other things are common. You have to somehow determine the temperatures up to this portion, and later use this simple formula for determining mass of air, and later on the COP is to be determined. And please go through some other question. I will cover up all the questions. Your queries are most welcome over here. Thank you.